Okay, so to start off, what do you see in the picture at the top?
Circle.
What is a circle?
I see a cord.
A cord. I do have a lovely cord right there.
Tangent.
Oh, a tangent. Those are fun too. Okay, yep. Oh, the cord touches the tangent. Where does the cord meet the tangent?
One singular spot.
Yeah, and it's got a fancy math name.
The point of tangency.
There you go. So if a tangent and a cord, intersect at the point of tangency, they make an angle. Do you see the angle?
Yes, ma'am.
It actually makes two angles, doesn't it?
I suppose.
It makes an angle on the right and an angle on the left. And since a tangent is a line, what's going to be true about those two angles?
They're
They're a linear pair, so they're supplementary, which adds to 180. Cool. But what kind of angle is it?
straight angle.
Well, that's what the tangent is. What kind of angle does the tangent make with the chord? It makes two adjacent angles. What kind of angles are they? If their vertex is on the circle. It's an inscribed angle. Does it look inscribed? No, because one of the tangent is dangling out the outside. But is the vertex still on the circle? Yeah. So it's just a circle that's gotten overheated under the blanket, so it kicked its foot and its leg out, so it's not so hot. Any of you ever done that before?
Yeah, I do
Yeah.
every night.
So you're not so hot, but this is still an inscribed circle. So, oh, wait. So it's an inscribed angle. But if it's an inscribed angle, the measure of the angle will be how much? Half the measure of the arc. And so over here on the right, this angle takes up this whole arc, intercepts the whole thing there. So if I just knew how big that arc was, I could just cut it in half and boom, I know the angle. But wait, I can also do it on the other side. Magic. Are you impressed yet?
Very much.
Oh, I can tell. Okay, so attempt example 1. Find the measure of angle 1. I'll give you 5 seconds.
What?
Well, there's angle 1. What kind of angle is it? Inscribed, and the angle will be half the arc. The arc is 210. So how big is the angle?
105 degrees.
105. Don't make it harder than it is. This is not a tattoo parlor. Okay? Oh, problem B.
196.
It wants, oh, this one's going backwards. It doesn't want the angle, it wants the arc, and it wants major arc, RST. So it wants this guy over here. Oh dear, I only know that the angle is half the arc.
Double it.
Oh, so if the angle is half the arc, then the arc must be
Double it again.
double the angle. So what's double 98?
196.
Be 196. Okay, you may yet survive this. Oh, what's it asking for on number C, on example C?
The arc.
Which arc?
XY.
Which arc XY?
That's what I'm saying. The only one with the angle.
I told you on day 1 how to tell.
The one with the angle.
How many letters are here?
Oh.
So which arc are we looking for?
The smaller one.
The minor arc, the smaller one. If they wanted the major arc, they would have used 3 letters. But they wanted the minor arc, so you automatically go the smaller way. And so how big would that arc be? It's going to be twice 80, which is 160. Now double check. Double check. Is that really a minor measure?
Yes.
Okay, good, we did the right one. If you had accidentally done the other way, you would know that, oh wait, I did the wrong one if you got something bigger than 180. So that would give it away. Cool, so that's doing those. Questions about doing tangent secant stuff? What's it look like on your formula chart? Does it say this? How'd you want to bet it doesn't? It doesn't. Does the picture look the same? Yes, but instead of words, it says the measure of angle 1, and you have to know that that's an inscribed angle with a tangent and a secant, is half the measure of the arc. You have to know what the stuff is saying.
Yes.
Well, I'm waiting for people to be done acting like a fool, so that, they aren't distracting me and or other people who sit near them. They know who they are. Okay, so now in a circle there are different ways that lines and chords and secants and things can cross. You could have lines crossing on the circle, like that. What kind of angle, if you cross on the circle, what kind of angle do you end up with? Inscribed angle. Okay? Or your two lines or your two chords or your two whatevers could intersect inside the circle, but not at the center. Okay? And that's going to form this kind of angle. It's not a central angle. How come? It's not the center. Is it an inscribed angle? No. So it doesn't meet any of the rules we just did. Now, could I extend this one just a little bit further across? Yeah. And this angle are related how? And what do we know about vertical angles? So if I knew one of them, could I figure out the other one?
Yes.
Cool, good to know. I still don't know how to find one of them, do I? Because it's not inscribed and it's not central. Okay, well that sucks. And so then you go, okay, where's another place my lines or chords or segments could meet? Outside the circle. It looks like this. Two secants crossing outside the circle. Okay, does that make an inscribed angle? Sadly, no. So I can't use my inscribed angle rule. Ooh, is it a central angle? No? So I don't know how to do these ones either. So these are the two we're going to get rules for today. Because we already did central, we already did inscribed. Now we got to do the stuff floating around in somewhere and the stuff that meets outside the circle. Guess which one we're doing first?
The one inside.
The one where they cross inside the circle. Okay? And what you end up with is basically a couple of chords that are meeting at angles. So let's see, angle 1 is right here. Okay? And I want to find the measure of angle 1. But wait a minute. Isn't this the same size as angle 1 over here?
Yeah.
Okay. So either one of those, if I could just find either one, I'd be fine. Problem. Look at angle 1 on the right and see the arc it intercepts. It's kind of big, huh?
Yeah.
But what about this angle is the same size, but does it use the same size arc?
No.
Don't trust the picture.
So which arc? Oh, well actually, it's true that that can happen. So I'm going to make a set of angles that are going to intersect inside my circle. Notice I'm not going to change the angles inside, but if I just move it over, do my arcs change?
Yes.
Yeah, the one on your right is smaller, the one on your left is bigger. What if I move it this way? Have I changed my angles? No. But now the one on your left is smaller and the one on your right's bigger. So which one do you use? Well, one of them's too big, one of them's too small. What could I do instead? I could get Candy for that. You can average the arcs. So you can say, okay, I'm going to do half of, let's do the measure of arc AB, and then the measure of arc CD. If I average these two arcs, it gives me the measure of one of these angles inside. And of course, if you know one of them, its vertical angle is exactly the same. Magic! Does it work for angle 2 as well?
Yes.
Yeah, but I would have to use this arc down that it's being intercepted and that arc that it's intersecting. Okay? So, on your formula chart, this is what it says as a formula. Does someone want to put this into words? Candy, for someone who wants to try to make it words out of this? Okay, fine, I'll do it. An angle with the vertex where? Where's my vertex of my angle? Inside the circle is found by 1/2, oh, my pen's running out, 1/2 the sum of the arcs. And it's the intercepted arcs. Let me put intercepted arcs. Arc, 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 arc. So let's attempt to see how we're going to use that. Down here, I want the measure of angle X. What arc does it intercept? And if you need to draw the snow cone, draw the snow cone. You intercept KL, but what else does it intercept? Remember, you're going to go backwards and draw its vertical angle, and you're going to intercept the arc on the other side. And X is going to equal what? It's an angle inside the circle. So what's our rule?
Yes.
Half the sum, and so 130 plus 156. And a bunch of y'all have calculators, I saw.
143.
And so it'll be half of 286. And X will be, how much is half of 286? 143. Notice, 143 is between these two numbers. One arc is too big, the other arc is too small, but when you average them, it's just right. You get to be Goldilocks. By the way, does this work if your angle is in the center?
No. Yes.
It does. But if your angle is in the center of your circle, the arc on the left equals the arc on the right. And so when you average two things that are equal, guess what you get? Equal things. And that's why the central angle equals the arc. Because if you put it in this formula, you get that it equals the arcs. Because the arcs are the same on both sides. Kind of a fun bonus fact that it's actually not a special formula for central angles. They're using this same formula, I just gave you the lazy version first. Okay, attempt this other example. Right here. Argue with each other about it. You want to find, ooh, it's the arc we're finding this time. Good times. Alrighty. How do you think we should attack this one? Because you can't attack it directly. I want arc Y. I'm sorry, what? Okay, well, look, what is the arc intercepted by? It's an angle that's inside the circle.
Yeah.
Okay, what formula does that use? Yeah, the angle, oh, do I even know that angle? Dang it, now what do we do?
Vertical angles?
Well, this would be a vertical angle, but do I know that vertical angle?
No, but you know.
Dang it, that didn't help me either. Somebody else now, what can I do? Yeah? How?
Subtract 1 of 3.
Oh, look, this is a linear pair, isn't it? So if this guy's 102, how big are our vertical guys going to be?
78.
They're going to be 78 degrees each. And how do I get that angle using the arcs? What was my formula using the arcs? The angle was 1/2 the sum. What two pieces am I summing?
95.
The y up here and the 95 down there. So see, you have to know the formulas so that you can drop stuff into them. You won't know the formulas if you don't know what you're looking at, so you can find it on your formula chart. Because that's just theorem 12 right here. The angle equals half the sum. But if you don't know what you're looking at in your picture, you can't use the formula. So you have got to get comfortable with all the terminology and what it looks like. Once you have this, how many of you love distributing fractions? Think it's awesome, you always want to do it?
Oh, yeah.
A couple people do. What if you don't like distributing fractions? How could I get rid of that stupid half?
Multiply.
Multiply by its reciprocal, so multiply by 2. But if I do it on the right, do it on the left. And now the 2 and the half will cancel out, and you're just left with y plus 95 over here. And the 78 makes what, 156? And so someone with a calculator, will you figure out how much y comes out to be when you... 61, you said? And you would be so close to being right. You'd put your degrees and you'd be done. Now let's see if it makes sense. Shh. How big was your angle? It was 78. Are 95 and 61 on either side of 78? Yeah. So it made sense. We needed one smaller and one bigger. We've got one smaller and one bigger. And so, yay, we must have done it right. Turn it over. That was inside the circle. Now guess where we get to go? Outside! So you go outside the circle, and look, there's 3, why do you think there's 3 different pictures here?
How do you know?
Look at them, what's different? Talk to each other and figure out what's different about the 3 different sets of pictures. Talk to each other.
Two outside.
And I need a table that everybody at the table wants candy
I got it.
to elect their spokesperson
Elliot is a spokesperson.
to get candy for the entire table by getting this right. She's like, Elliot, are you being voluntold?
Yep. Okay.
Okay, well, if he gets it wrong, y'all get a stab at it. Okay, so these all intersect outside the circle. What's different about them? What's the first one?
So the first one has a tangent, and the other one is a chord.
This up here?
Yeah.
Sadly, that is not a chord. Reese?
Alright, so the first one is one tangent and one
The
secant.
first one is made of a tangent and a secant.
The second one is two tangents.
The second one is made of two tangents.
And the third one is two secants.
And the third one was two secants. Seriously, the answer was right there. Okay, now y'all cooperated well on that, so y'all go get your candy. The ones that intersect the circle twice.
With a cord.
A chord is just the segment inside. Okay? A chord is a piece of a secant. Okay? Shh! Okay, next one, I need a table to argue together and pick a volunteer to tell me, look at the formulas for all three of these. They tell you how to find that outside angle. I want you to tell me in words, what is the formula saying to do? Just in general, because it's saying the same thing on all three of them. So look into words, a nice, short, simple way to explain all three of these rules. Talk amongst yourselves, argue about it.
Oh yeah, it was mine.
Is it averaging?
No, because you track it.
Okay, so how would you say it? If you can't use the word average.
Apply the...
Hey, can we do it again?
What's the subtraction word? It's not sum.
Difference.
Difference. That's why you have to...
Okay, what table thinks they've got some good words for this? And there might be more than one way to say it, so we're going to give a couple people a shot. Who's the spokesperson here? Okay, go ahead.
We said the measure of the angle
Hold on, the measure of the angle outside
is
is
1/2 the big intercepted arc
the big arc
minus the small arc.
minus the small arc. What do y'all think? Do you think that describes it pretty well?
I would say so.
Let's go up and see. This one says this angle outside the circle, okay, is 1/2. Arc BC is definitely the bigger arc. The bigger one is always the one further away, isn't it?
Yes.
Because the angle gets bigger the further away you go. So your big arc minus your small arc. Okay, that worked for the first one. On the second one with the tangents, I've got 1/2 PQR. Oh, that's a big fella. That's a major arc. And the minor arc. Okay, so big arc minus little arc. Okay. And then for this one, the outside is half the big arc is XY and WZ. I believe it. Good job, team. Go get your stuff.
Yes.
Okay? So it's always 1/2 the big arc minus the small arc. Can you think of why we subtract there? Because the angle is smaller. Remember, when we were meeting somewhere just randomly inside the circle like this, you've got kind of a big angle, don't you?
Yep.
I don't have everybody's eyeballs. And then if you stretch it out to the center, the angle's gotten a little smaller, hasn't it? It's now equal to the arc. If I stretch it out even further to an inscribed angle, it's half the arc. But if I stretch it out even further, it's got to get even smaller. And so I need something smaller than either of those arcs. And that's why you subtract them before you do a half, is to get it really small. That can help you remember. When it's outside, it gets really small, and so you need to subtract. Otherwise, where can you find all of this? On your formula chart? On the back side? But it doesn't use the nice simple words. It uses the formulas. But now you've talked about it and heard us say that, oh, No, it just means the measure of the angle outside is half the big arc minus the small arc. So let's attempt one. Get together with your team, figure this fella out. Set it up, you gotta write down the algebra. I know, it may yet drive you crazy. We're almost done, and then you get to quiz.
30 equals 4
Who's ready to quiz?
It'll be FG.
That's what we call myself.
Half this one. See? Yeah. So it equals X.
Page number 2.
Okay.
And this time I meant an individual. Earn the candy.
I like to do it different than she does it though, because I don't like that.
Okay.
This is a lot more.
Okay. So here's your formula. Shh. Someone tell me what you set up in your formula. Wow, y'all are not very brave. Okay, yes, look,
So they gave us the angle,
which is how big?
30,
So the angle outside is,
30.
yeah, there it is, and it is,
1/2 big arc, which is X,
okay, big arc is X
and they give us small arc, so minus 40.
minus 44. You set it up, get your candy. See, if you know the formula, you just have to plug in your pieces. But now you have to solve it. So how am I going to solve this? What do you think?
Multiply by 2.
I could double both sides to get rid of the fraction, or I could distribute. But I don't like distributing, so that's going to be 60 equals X minus 44. Okay, continue. Don't let me stop you, Quentin.
Oh, okay. And then you add 44 to both sides.
And what do you get?
You get 104.
Yeah, 104. I think that's worthy of candy.
Oh, okay.
Questions, problems, complaints, concerns, or comments? Bonus fact! See all this empty space? You get a bonus fact. Draw a circle. Draw a center. Call it D. And then I want you to draw 2 radii out to the edge. And let one be end at A and the other end at C. Then I want you to draw the tangents to those. And remember, the tangents will be perpendicular. And they're going to meet somewhere outside your circle. And let's call that point B. Okay? And your bonus fact of the day is, if tangents, hey, okay, if they meet, where are my tangents meeting, inside or outside?
Outside.
Always outside, because they never go inside. So if they meet outside your circle, guess what's going to be true about that central angle and this little pointy outside angle? Somebody just make a guess.
Supplementary.
They're supplementary, you get candy. The central angle is supplementary to the outside angle. And that's just sort of a bonus fun fact that you can use to save yourself work on some of the problems you're going to be doing, so you don't have to draw a bunch of congruent triangles and do all that junk. So this little guy in here is going to be supplementary to that little guy out there. Good times. Y'all ready to quiz? Okay, clear everything off, including your formula chart, and get a calculator. What you got?
You're good, you have now.
Okay. Don't write you in the library.
Oh, okay.
He said the E word.
And we can't feel.
Oh, yeah.
I need to pick volunteers who want to pass out quizzes and formula charts. own formula chart, you have to use mine.
Is yours green? Yeah.
Same thing.
What's the difference between mine and yours?
You could have written on yours. Well, no, it's not cheating.
I'm sorry.
You just don't get that extra help.
He gave you that because he wanted.
Okay, who wants to pass
I'll
the...
pass them out.
You'll pass that, we'll pass that formula chart.
Oh my goodness.
So, calculator and colors and pencils and stuff.
Come on, Elliot.
What?